This is Chapter 9, Solving Quadratic Equations, and 9.1, Properties of Radicals, Part 1. A radical expression is an expression that has a radical in it. A radical is the square root symbol. In simplest form, with some index, we cannot have any radicals that can be reduced any further. So we cannot have a perfect square or a perfect cube if it's a cube root. We can't have those in there. We cannot have a radical in a fraction, and we cannot have a radical in the denominator of a fraction. So for the product property of square roots, the square root of a product equals the product of the square roots. So the square root of a times b is the square root of a times the square root of b, where both a and b are greater than 0. So if we have the square root of 9 times 5, that's the square root of 9 times the square root of 5, which we can simplify to 3 root 5. The square root of 75, we can break that apart into the square root of 3 times 25, which we don't know the square root of 3, we do know the square root of 25, so it's 5 root 3. Square root of 16x to the third is the square root of 16 times x to the third. We can split this x to the third into an x squared times x, and we get the square root of 16 times the square root of x squared times the square root of x, which reduces down to 4x times the square root of x. Then we have the quotient property of square roots, which is very similar, except the quotient equals the quotient of the square roots of the numbers. So again, we split it. Square root of a over b is the square root of a over the square root of b, where a can be 0 or greater, and b must be greater than 0. So for the square root of 3/4, that's the square root of 3 over the square root of 4, which we can simplify to the square root of 3 over 2. For square root of 23 over 9, split the square root and simplify the square root of 9. Square root of 36 over x squared, we know the square root of 36. The square root of x squared, the squared and the square root cancel each other out to just leave x. The cubed root of a over negative 27. We're going to split that, and we know the cubed root of negative 27 is negative 3. Alright, now this one gets a little tricky. If we have the cubed root of 25x to the 7th y to the 3rd over 64, we're going to split the cubed root into top and bottom. This x to the 7th I can rewrite as x to the 4th times x to the 3rd. Remember, when they have the same base, you can add the exponents together. So that will be cubed root of 25 times the cubed root of x to the 4th, the cubed root of x to the 3rd, and the cubed root of y to the 3rd over the cubed root of 64. This x to the 4th here, we can split again into the cubed root of x times the cubed root of x to the 3rd. We want to make as many matches with the index and the power as possible because they will cancel out. This is just x. So coming over here, from here to here, we have the cubed root of 25 times the cubed root of x times the cubed root of x to the 3rd times the cubed root of x to the 3rd times the cubed root of y to the 3rd over the cubed root of 64. Now we can simplify these, and we get the cubed root of 25 times the cubed root of x times x times x times y, because the cubes and the cubed root cancel out, over 4. Now I have x times x, so we write that as x squared. And this is the answer.